Hey guys, hope you're having a good day today. Just wanted to go over with you what the plans are for this week, as well as to talk about the digestive system in this video, and maybe show you a couple of examples of things that you're going to be doing. So, uh, I've given you yesterday and today to complete your heart test. Again, everything this week will need to be completed by Sunday, April 26th at 11:45 or 11:55 p.m. and the specific time 11:45, 11:55 will be on the assignment. Your heart unit test, again, I have set aside for yesterday and today. Again, it will be open until Sunday night, so if you don't get to it until later, that's fine, but today and yesterday were for the heart unit test, which posted on Google Classroom yesterday morning. Then on Wednesday, tomorrow, we are starting with the digestive system. So you're hopefully going to watch this video first. I've also posted the learning targets, the PowerPoint, as well as the notes handout over this unit. Now, you do not have to print out and complete that notes handout unless you want to, so that you'll have that information there for you to look at and use and study. But I have put it on there if you want to print it out. We're looking at the different organs of the digestive system and their structure and function. After you've watched that video, again, you can use the PowerPoint as well. You have the Digestive System Interactive Notebook. It's similar to the interactive notebook over the heart last week. So if I open that up real quick just to kind of show you, if you did it last week, then this one won't be any big deal. But it is colored in blue. I have a place here for you to put your name on the very first slide. Again, this slide, when you open up the assignment and click on the interactive notebook, that is going to be just yours. So even if you don't put your name on it, I'll still know whose it is, but I did put it there. Again, the Google Classroom is making a copy of this for each student, so you will have your own. You don't have to make a copy of it. You will, when you click on it, that is yours. That will be what your assignment that you will submit. Again, I have put the instructions, so you're going to be dragging boxes to label the digestive system. Again, so this is the box, and you're going to drag the pink box to the white box, wherever it goes, to label the digestive system or digestive tract. You're going to also be labeling the parts of the stomach. You're going to be labeling the parts of the digestive organs. Specifically here, we see some of the other digestive organs, but you're mainly labeling the parts of the small intestine and large intestine here, but you're also seeing some other organs as well that you'll be labeling. And then lastly, this is kind of like a worksheet where you are going to be filling in these blanks, which are these empty white boxes, to kind of trace the flow of materials through the digestive tract and the digestive organs. So again, you will need to watch the video, use the PowerPoint, and you should be able to do this pretty easily. Please let me know if you have any questions about it. Okay, the other thing that you're going to be doing is a review quiz on quizzes. Now this is something that I don't think we did last week. I think this is the first time we've done this. But anyway, the Digestive System Practice Quiz is the quiz on quizzes. I have sent everyone an invite via email to join our quizzes class, so please use that invite to join our quizzes class. Once you have joined that class, then you can click on either of these links. It has it where you can do it on a mobile device like your phone or an iPad, or you can do it on a laptop or a home computer, and it's got, I think, like maybe 25, I think it's got 30 questions on it, and you'll have 30 seconds to answer each question. It's kind of a game if you've ever played Kahoot. It's very similar to that. Again, after watching the video, completing the interactive notebook, I feel like you should be able to do this pretty easily. You'll have the PowerPoint at your disposal. Also, you know, you may want to do this before you submit your interactive notebook. But anyway, it's 30 multiple choice questions, and you get 30 seconds per question, and it's just a really good review. Also, I wanted to let you know that you can take this quiz multiple times. I've fixed it where you can take it as many times as you want to practice, and I will take the quiz, the grade that you have when it shuts off, and this will shut off at 11:45 p.m. On quizzes, I can't shut it off at 11:55. I can shut Google Classroom off at 11:55, but I can't shut quizzes off at 11:55. So therefore, this quiz will close at 11:45 on Sunday evening. So you want to get it done before Sunday evening, April the 26th at 11:45. Again, as I said, you can take it as many times as you want, and it will, and I will count. I don't know whether it keeps up with the high score you got or if each new score replaces the old one. I'm not sure. I've not used this program or this website a whole lot, but I think students do enjoy it. So whatever your score is, when it shuts off at 11:45 p.m., that will be the score that I will put in Infinite Campus. So please let me know if you have any questions about these assignments. I'll be happy to help you with those. Also, as you can see here, we're going to be spending Wednesday, Thursday, and Friday on the digestive system, doing the video that I'm making now, the interactive notebook, and the quizzes. And then next week, at the beginning of the week, you will have a quiz over the digestive system. And then we will be starting on the nervous system. We'll do nervous system next week, and then we should be ready for finals. So I wanted to talk about the digestive system today. Again, like our heart video last week, there are going to be videos that I have in the PowerPoint that you probably would want to go watch, simply because that will have information. It will have animations, pictures, things like that will help you to understand all this material. So please take advantage of those videos. I'm not going to show them on here because if I do, YouTube will probably flag my video and take it down. So I will just show you the slide that it's on, and then you can actually go to the PowerPoint that I've posted on Google Classroom and watch these videos. So the very first video here is just an overview of how your digestive system works, probably a really good overview. Also, guys, these videos will help you a ton with that last slide on that interactive notebook about all the different organs and what they do and the way that food moves through. So these videos will definitely help you a ton with that if you struggle with that. Okay, so we have different names for our digestive system. It can also be called the alimentary system or alimentary canal. In addition, the gastrointestinal tract or GI tract. It is a continuous muscular tube that runs from your mouth to your anus, and its functions are digestion and absorption. Again, it includes your mouth, your pharynx, your esophagus, your stomach, your small and large intestines. That's your actual GI tract or alimentary canal. We also have accessory organs to the digestive system. What this means is that they are not part of this tube, but they do contribute. They help it. They contribute to the digestion of your food. Accessory organs include your teeth, your tongue, your gallbladder, your liver, and your pancreas are going to be the major ones. We could put your salivary glands in there as another accessory organ. Again, these are not part of the tube that extends from your mouth to your anus, but they do help that tube to do that digestion of the food. So we have some different processes of digestion that we want to look at. First of all, ingestion means eating, taking in food. Mechanical processing, this includes all of the physical manipulation of the food to break it down into smaller pieces. So the squashing, tearing, and crushing in the mouth that happens with the teeth and the tongue, as well as segmentation, which is basically mixing and churning of food in both the stomach and the duodenum of the small intestine, where the food is, due to the muscular contractions of the walls of the stomach and the small intestine, the food is mixed with gastric juices and digestive enzymes. Digestion, this mechanical processing we could actually call mechanical digestion because it is the physical breakdown of the material into smaller pieces. This digestion here is the chemical digestion. It is the chemical breakdown of food by the digestive enzymes. You have one digestive enzyme in the saliva in your mouth. You have another in your stomach, but most of the digestive enzymes are produced by the pancreas and they are released into the duodenum of the small intestine, and they do the chemical digestion or the chemical breakdown of food. Secretion is just referring to the release of the enzymes. Enzymes are released by your salivary glands. They're released by gastric glands in your stomach. They're also released by the pancreas. We have some secretion by the liver as well. So it's just the secretion or the release of enzymes and other digestive juices by the different organs of the digestive tract. And then absorption, guys. Virtually all absorption happens in the small intestine. What is absorption? It is the movement of these organic molecules from your food across the epithelium of that small intestine into your bloodstream so that those organic molecules can be used for nourishment of your cells. And then lastly, defecation, also called elimination. Defecation, you guys, is literally pooping. It is eliminating the solid waste. So once the material gets into the lower portions of your large intestine, all it is just waste material that cannot be used by your body for anything. And so it is eliminated from your body, which means you poop it out. And that process, the technical term for it is defecation. Okay, we also need to look at two movements of the digestive tract. You guys, you have a couple of different layers of smooth muscle in the walls of your digestive tract, and those two layers of muscle do two different types of movements. The first movement that they do is called peristalsis, and this is the forward movement of materials in the digestive tract. So again, moving the material from one area of the tube to another, from your mouth to your esophagus, from your esophagus to your stomach, from your stomach to your small intestine, from your small intestine to your large intestine. So the forward movement of material from your mouth to your anus. The other movement is called segmentation. This does not involve any forward movement of the material. This is the mixing and churning of the food in your digestive tract, mixing it and churning it, combining it with digestive enzymes, acids, other secretions so that digestion can occur. So basically you can see in this diagram we have some white material and brown material. As segmentation occurs, it becomes tan, okay? So we're not moving it forward, we're just sitting there mixing and churning it. This mixing and churning called segmentation mainly happens in two areas of your digestive tract, and that is going to be in your stomach. You have a lot of segmentation happening in your stomach, mixing and churning that food that you have swallowed with the acids and other juices of the stomach, as well as in the duodenum of the small intestine, where the material that leaves the stomach, which is called chyme, goes into the duodenum of the small intestine, and it is mixed and churned with bile from the gallbladder and liver, as well as digestive enzymes from the pancreas. Okay, the next video it looks like that we have is actually not there anymore, so we're going to go ahead and get rid of that. But anyway, I will try to find another one and put on there. But we have 4 layers in the wall of the digestive tract or the alimentary canal. The first layer is not really a layer, it's called the lumen. Again, we're starting from the inside out, so we're starting deep and going superficial. So in the very center of your digestive tract, you have the lumen. This is not really a layer, but it is just an opening. It's the opening where the food will move through. The next layer you have is called the mucosa. The mucosa is a mucous membrane that lines that digestive tract. Again, that mucus is going to help with neutralization of acid. We'll talk about that more later, as well as just lubrication, making the material more slippery and easier for it to move through the digestive tract. The innermost layer of this mucosa is an epithelial membrane. If you'll remember, it's probably going to be simple columnar. Simple columnar contains is the layer of epithelial tissue that we find lining the digestive tract. It also contains goblet cells which secrete mucus. And again, it is mainly going to be used for secretion of mucus and other materials. In your small intestine, it's going to be used for absorption of nutrients, and also, again, as I said, protection. Protection, protecting your the other layers from the acids and chemicals in the food, as well as protection from friction, just kind of helping to lubricate to help help the material slide through the digestive tract more easily. And then under the, should be on the outside, not under, but on the outside. Again, we're going from the inside out. The submucosa, which is basically under the mucosa, but under here is on the outside of the mucosa. It is just external to the mucosa. It contains blood vessels and nerve fibers, and it gives your digestive tract walls a little bit of an elastic characteristic. Moving on, we have the muscularis externa. Again, this is going to be on top of or external to the submucosa. This is going to be our layers of smooth muscle. There are 2 layers of smooth muscle, the inner circular layer and an outer longitudinal layer. So the circular layer, again, goes around the tube, and then the longitudinal layer runs parallel to the tube. And this is the actual layer, the muscularis externa. This smooth muscle is responsible for the peristalsis and the segmentation. Again, remember, the peristalsis is the forward movement of the material. The segmentation is the mixing and churning of the material in place. And then the outermost layer, which is actually part of our peritoneum, if you remember, the peritoneum is the serous membrane that lines most of the abdominopelvic cavity, called the peritoneal cavity. The serosa is the outermost layer of the digestive tract. It is part of the peritoneum. And it is composed of epithelial tissue. Remember, those serous membranes contain simple squamous epithelia and also connective tissue. And then here we can see it. Again, here is our lumen, the innermost area, the opening where the food moves through. Then we have our mucosa here. Let me see here. Then we have our submucosa. Then we have our muscularis externa. And then we have our serosa. So those are the layers that we just went over. The mesenteries, we need to talk about those. Again, those are part of the peritoneum. The peritoneum, remember, is the serous membrane that lines and lubricates the peritoneal cavity, which is around all of our digestive organs. And our serosa, remember, is part of our peritoneum, and the mesenteries are also part of our peritoneum. They are double sheets of peritoneal membrane. We're not going to worry much about the ventral and dorsal mesenteries. Just realize that there are mesenteries on the ventral side of your abdominal pelvic cavity. That's going to be over the stomach. And then we have dorsal mesenteries that hang from the back of the stomach, and they're kind of on the posterior side of the abdominal pelvic cavity. And so you can see this is going to be more that ventral, and then this is going to be some of that kind of dorsal. Why are mesenteries important? Well, remember we talked about how the peritoneal membrane helps to lubricate so that there's not as much friction, because remember, these digestive organs, this digestive tract is moving as those circular and longitudinal layers of the muscularis externa contract to move the material forward and to mix it and churn it. But there are other functions as well. Again, this is part of the peritoneum here, or the mesenteries. And these are actually mesenteries that are found kind of in between all the loops of the intestines. So this is intestine here, and these are mesenteries in between those loops of intestines. The mesenteries are important because, number one, they suspend the intestines, portions of the digestive tract within the peritoneal cavity, so they kind of hold them in place. They also provide an access route for blood vessels and nerves. So all this pink and blue that you see here, guys, this is latex that has been injected into this animal that's being dissected, so that we can see the blood vessels, the arteries and veins. And so we can see that we have arteries and veins running through these mesenteries. And remember that nerves usually run along with arteries and veins. They all run together through all the tissues. They take the same route. So we have blood vessels and nerves that run through the mesenteries. So we don't have, in our body, we don't have blood vessels and nerves just running through thin air. Like the electric lines do outside. Our blood vessels and nerves have to run through tissue because this kind of helps to stabilize them and support them and protect them. So these mesenteries give a route. They provide a passageway for these blood vessels and nerves to run to all the different layers, to all the different parts of your intestines. Again, we've not talked about this yet, but you're going to have about 30 feet of intestines in your abdominal pelvic cavity, and they're just big loops of intestines, and those blood vessels and nerves have to have a way to run to all those different areas of the intestines to make sure that they're getting the oxygen and nutrients that they need, as well as carrying away the carbon dioxide. The last thing that our mesenteries do that's very important is they stabilize the position of our intestines and prevent them from becoming entangled. You guys, you have 30 feet of intestines looped around in your abdominal pelvic cavity. This is kind of like having 30 feet of rope. If you did not have something to kind of organize and stabilize them, then they would end up in knots. And sometimes they do anyway. Sometimes the intestines end up becoming knotted and entangled, and you end up with blockages, and people have to have part of their intestines even removed. And if they don't, it can result in death. So these mesenteries help to prevent that from happening. It can still happen, but it's a lot less likely because you have these mesenteries kind of stabilizing and holding these intestines in an organized fashion in your abdominal pelvic cavity, so that you don't have these knots twisting and forming from these around 30 feet of intestines that you have in that little area. Okay, so now we're going to actually start looking at the tube, and we will kind of take a side road, and we'll look at the accessory organs when we get to the point of talking about the small intestine, but we're going to start with looking at the tube. So we're going to start with our mouth. Another name for your mouth is your oral cavity. Remember, oral or orus is mouth, or your buccal cavity. Remember, bucca is cheek. So the buccal cavity is the cavity that is enclosed by your cheeks. The oral orifice is actually what we can call our mouth. Our mouth, what we call our mouth, is the anterior opening, the oral orifice. But your mouth actually includes all that inside of that oral orifice. It is lined, remember, by stratified squamous epithelium, protecting the tissues underneath from the chemical and mechanical stresses of all the different food and the chewing that you're doing in your mouth. And it is the only organ involved with ingestion, which, remember, means eating. Here we can see this is our oral orifice. Here is our oral cavity. Back here at the back, we have our, notice how big your tongue is. Back here at the back, you have a tonsil. You also have your uvula. Your uvula we'll talk about in just a few minutes. So let's look. Our lips, another name for our lips are the labia. They are surrounded by the orbicularis oris muscle, which is basically the muscle that helps to purse your lips and close your mouth. Also, we have our cheeks, which remember are our bucca. We have buccinator's muscles that kind of help to move our cheeks and help us with our speech. And these two together help to keep the food between the teeth as well as help with speech. We also have our gums, which our teeth are embedded in, and our gums are called gingiva. You've heard of gingivitis, which is inflammation of the gums. So here you can see your gingiva, which are your gums. Here you can see your superior labia, your inferior labia. Again, you can see your tongue, which is just really a huge muscle. We also have our palate. The palate is the roof of your mouth. You actually have two parts of that palate, the hard palate and the soft palate. The hard palate, you guys, if you put your tongue behind your teeth and you move your tongue backward toward the back of your mouth, you can feel the hard palate, and then you can feel where it transitions to the soft palate. The hard palate is useful because food is forced against it by the tongue, and again, that just helps with that mechanical digestion, that mechanical processing of the food. And then the soft palate has an extension hanging from it called the uvula. You know, that little thing that hangs down in the back of your throat that you kind of have to say, ah, to try to lift it up so that the doctor can see the back of your throat when you have a sore throat, maybe have strep or something like that. Well, there is a purpose for that little thing hanging down in the back of your mouth. It's called the uvula, and the purpose is to prevent food from traveling up into your nasal cavity. So when you're eating and you swallow, that uvula lifts up and blocks the nasal passage to help prevent food and drink from going up into your nose. So again, as you can see right here, this is the uvula. Here is your nasal passage, part of the nasopharynx, which we'll talk about in a few minutes, and that uvula kind of when you swallow, lifts up and blocks this nasal passage so that the food will go down the throat and not go back up into the nose. Looking at our tongue occupies the entire floor of our mouth. It is very important because it helps to position the food between your teeth so that you can chew it and mechanically process it, mechanically digest it better. It also is the home of the taste buds, which we call lingual papilla, and we'll talk about those more if we have time in the nervous system, but basically they are your taste buds. It does have lots of muscles. It has intrinsic muscles that change the shape of the tongue, and then extrinsic muscles that change the position, which basically means to move it around, and both of those are obviously going to help with speech. Again, you can see your tongue here, very large. We can see the different taste buds. We have circumvallate papilla, we have filiform papilla, fungiform papilla. These are all taste buds. We also have some tonsils, which are just collections of lymphoid tissue, which are basically immune tissue. Okay, going on, looking at our salivary glands. Obviously, salivary glands produce saliva. Why do we need saliva? Well, number one, it cleans your mouth. When you have someone who is taking chemotherapy, it affects their epithelial tissues. It affects any tissues, any cells that divide quite frequently, because that's what cancer is. It's cells that divide very frequently. So chemotherapy targets cells that divide frequently. We know epithelial tissue cells divide frequently, so it targets all epithelial tissue. This is why your hair falls out. Another thing that happens is it affects your salivary glands because they also contain epithelial tissue that produces that saliva. If you remember, we talked about those American glands and apocrine glands and holocrine glands. Well, those, our salivary glands, some of our salivary glands are some of those, like merocrine and mixed glands. Whenever you do chemotherapy, it basically causes your salivary glands to stop producing saliva. And so therefore, people with chemotherapy who are doing chemotherapy really have to worry about tooth decay because, guys, that saliva cleans your mouth and your teeth. It keeps the bacteria washed off of your teeth, and so it keeps you from having a lot of cavities. Now, obviously, we still get cavities, but we would get a lot more cavities if we didn't have saliva. So people who are taking chemotherapy have to go to the dentist very frequently and have their teeth cleaned because they're not producing saliva to wash those bacteria off their teeth, and so they can end up with tooth decay and losing a lot of teeth very quickly if they don't go to the dentist and brush their teeth often and keep their teeth clean because they're not producing saliva to clean their teeth. Also, you guys, we really wouldn't be able to taste anything if it wasn't for our saliva. Our saliva dissolves the chemicals in the food so that the particles from those chemicals can attach to sensory receptors in our taste buds and allow us to taste the food that we're eating. Obviously, one thing you did know about saliva is that it moistens your food. It helps to moisten the food to make it easier to swallow, to get down your esophagus, and it aids in the formation of a bolus, okay? If you watch the videos, you'll learn more about a bolus, but basically the bolus is the mixture of food and saliva that is formed in your mouth. It's a little ball that you swallow. So you don't really pay a lot of attention to it, but if you chew your food very good, then you will notice as you swallow it that it kind of forms this ball of material that is a mixture of the food and saliva, and then goes down your esophagus into your stomach. And then saliva also does begin the chemical digestion of food. There is an enzyme in your saliva called amylase that digests carbohydrates like starches. And so you begin a little bit of chemical digestion of carbs in your mouth as you're chewing because there's amylase in the saliva. We have 3 sets of salivary glands that we want to look at. The first set are called parotid glands. The parotid glands produce amylase, which I just talked about is the enzyme that breaks down starch. The sublingual salivary glands, the parotid glands, I'm thinking, are in front of your jawbone. The sublingual salivary glands are under your tongue. They produce a watery mucus secretion that acts as a buffer and a lubricant. So this mucus, guys, not only does it help to lubricate the food so that we can swallow it more easily, but the mucus also acts as a buffer. So we're going to see a lot of mucus being produced in our digestive tract. It acts as a buffer. And what buffers do is they help to neutralize acids. They help to neutralize the pH. So if you're taking in anything that is acidic, which a lot of our foods are acidic, then that mucus helps to buffer that pH, make it more neutral. And then if you're taking anything that's very basic, which most foods are not going to be very basic, but if you do, then again, that mucus acts as a buffer to help neutralize that and bring it more to a neutral pH. And then the submandibular salivary glands are going to be more below your mandible or your jawbone, and they are going to kind of do both of these, do the things that both the parotid and sublingual salivary glands do. So just another gland kind of doing the same thing. It's secreting buffers, mucins, which are like the mucus, have a lubricating action, and also that amylase that breaks down starch. So here's a picture. As you can see, here's our sublingual under our tongue. This is our tongue. Here's our sublingual salivary gland. Our submandibular salivary gland is here, kind of almost below the jawbone, which will be right around in here. And then the parotid is back here, kind of behind the mandible, back here in front of the ear. And actually, my mother had, she started noticing a little knot there in front of her ear, and she went to the ear, nose, and throat doctor, and she has a little tumor in one of her parotid glands. But we have a lot of facial nerves and things here, and so the ear, nose, and throat doctor just keeps a check on it. As long as it's not growing, he doesn't bother it. But if it were to ever start growing, then he would need to biopsy it to see if it could be cancer. And he doesn't want to biopsy it right now because there are nerves here, and he's afraid that if he tried to biopsy it, he might damage a nerve. But if the tumor did start to grow, then he would have to biopsy it, because even if he damaged a nerve and it affected this side of her face, it would be worth it if she had cancer, because then this gland would have to be removed. Okay, we also have, you guys, 32 teeth as an adult if you still have your wisdom teeth. If you don't have your wisdom teeth, you have 28 teeth as an adult. Again, those wisdom teeth are going to be molars. You actually have, in general, 3 kinds of teeth. You have incisors, canines, and then premolars and molars. Your incisors are going to be the teeth here in the very front that are kind of flat. These act like a knife. They clip and cut things. They are for clipping and cutting like a knife. Your canines are going to be the sharp ones kind of here at the corners on the top and the bottom. Canines for like dogs. Like dogs have sharp teeth. So the sharp ones that you have kind of there at the corners at the top and bottom are canines. And they are good for tearing and slashing because they're sharp like the tip of a knife. And then the molars and premolars are going to be all those behind the canines. They're going to be bigger and more flat on the surface, and they are good for crushing and grinding. So incisors are good for clipping and cutting like the blade of a knife. Canines are good for tearing and slashing like the tip of a knife. And then molars and premolars are good for crushing and grinding as you chew, because they are very large and have relatively flat surfaces. When we look at a tooth, we can see the different parts of a tooth. The crown is the white part that you can see. It's covered with enamel, which is the hardest substance in the human body. The neck is the part right here at the gum line. It kind of narrows a little bit. And then the root is down here below the gum line, cemented into the jawbone by some material called cementum. Inside the enamel, you have dentin, which has little tubules called dentinal tubules that lead to the pulp cavity. The pulp cavity, it contains the blood vessels and nerves. So if you have a cavity, which is basically where bacteria have dissolved your enamel, then that opens up these little dentinal tubules to the outside. And so air as well as food and drink that you take in can actually go through those little dentinal tubules down here to this pulp cavity where the nerves are and start hurting. So if you have a cavity deep enough that you're having pain, then that means that cavity has gotten through, it has dissolved a hole through the enamel, and air and food and water and drink are able to get down into this pulp cavity, which can cause infection, and it also is very painful. The gingiva, again, remember, are your gums. The cementum is the material holding that root in the jawbone. The periodontal ligament is basically a ligament. You'll talk about this more in your college anatomy. It makes the tooth a little bit flexible. If the tooth were not a little bit flexible in that jawbone, then any pressure, just like from crunching down too hard on something, could actually break the tooth. So this periodontal ligament makes that tooth a little bit wiggly. If you've ever noticed your teeth will wiggle just a little bit, if you move them, they'll wiggle. You notice just a little bit of movement. You're like, oh no, my tooth is loose. Your tooth is not loose. Your periodontal ligament just kind of helps to make that tooth a little bit flexible in that mandible, so that it doesn't crack or break from from too much force when you're chewing and biting down on things. And then, of course, this is your bone. This could be your mandible or your maxillary bone, depending upon which tooth we're looking at here. And then the apical foramen is just a little opening at the very end or apex of this root cavity, where the nerve and blood vessels are running on down into the jawbone. Okay, our pharynx. Now this may be a structure that you've not heard of before, but you use it all the time. Your pharynx is actually divided into an oropharynx, a laryngopharynx, and also a nasopharynx. It is the common passageway for air, food, and drink. So basically, it's at the back of your mouth, at the top of your esophagus. It's behind your nose, behind your throat, and at the top of your voice box, which is your larynx. So the part of the pharynx behind the nose is called the nasopharynx. The part of the pharynx behind the mouth is called the oropharynx, and the part of the pharynx above the larynx is called the laryngopharynx. So it's this kind of this long opening from behind your nose all the way down to the top of your esophagus, and air, food, and drink all pass through it. It does contain 2 layers of skeletal muscle that assist with swallowing. Again, a layer of longitudinal muscle and pharyngeal constrictor muscles. Again, these are just going to help with the process of swallowing. Again, these muscles actually initiate the process of swallowing, and the name of the technical word for swallowing is deglutition. And then this delivers that bolus, again, that ball of food mixed with saliva down the esophagus and into the stomach. So again, here is our nasopharynx behind our nose. Here is our oropharynx behind our mouth. Again, here's your tongue. You can see how huge it is. And then here's our laryngopharynx above our voice box, which is our larynx, which is going to be about right in here somewhere. So again, you can see that pharynx is a pretty long passageway where air and food and drink all pass through on their way to the esophagus. The esophagus is down here. Okay, let's talk more about the esophagus. The esophagus is a muscular tube that is collapsed when there is no food in it. It is actually posterior to the trachea, which is the windpipe. And I wish we had been able to dissect the rabbits, because we would have actually, at the neck, saw the trachea when we were dissecting the muscles, and then we would have actually cut the trachea out and looked at the esophagus, which is attached to the posterior side of the trachea. It is only muscle. Now, the trachea is cartilage, so it remains open all the time because it's more stiff. But the esophagus is purely muscle, and so if there's not something moving through it, it is flat and it's closed. Similar to the uvula, the epiglottis is another structure that we have that when you swallow, it folds down and covers the trachea so that your food and drink as you swallow goes down your esophagus and not into your trachea. Because remember, the trachea is in front, the esophagus is in the back. And it's still easy sometimes for food and drink to get into that trachea and cause you to choke. But that epiglottis helps to prevent that. Like the uvula, when you swallow, raises up to cover the nose. When you swallow, the epiglottis goes down and covers the trachea so that the food goes down the esophagus. The esophagus joins the stomach at what we call the cardiac orifice. And again, remember the esophagus is is in your throat going, it has to go down your chest cavity and then enter your abdominal cavity to get to your stomach because it joins the stomach. The esophagus joins the stomach. So our esophagus goes all the way down behind our heart and through the diaphragm. Because remember, the diaphragm separates our thoracic cavity from our abdominal pelvic cavity. You have to have an opening in that diaphragm for the esophagus as well as blood vessels to get through the thoracic cavity and down into the abdominal pelvic cavity. This opening is called the esophageal hiatus. So in the diaphragm, you have an opening that the esophagus goes through to get to the stomach and attach to the stomach, and that opening is called the esophageal hiatus. Now, this opening can tear. If this opening tears, this is called a hiatal hernia. So you can have a tear in this esophageal hiatus in the diaphragm, and that tear would be called a hiatal hernia. And you guys, I want to give you a little story about what happened with my uncle's ex-wife. She was probably in her 40s, and she was having a lot of chest pain. And they thought that it would be odd that she would be having heart trouble, but she kept having all this chest pain. So she went to doctors, and they did all kinds of tests on her heart and couldn't find anything wrong with her heart. And then just so happens up here at the Monroe County Medical Center, they decided to do an x-ray of her chest to see if they could see anything in there causing pain. When they did an x-ray of her chest, you guys, a lot of her intestines were up in her chest. This is why she was having chest pain. Imagine. How did that happen? Well, obviously, she had a hiatal hernia. She had a tear in that esophageal hiatus. And it was large enough that over time, her intestines, part of her intestines, had worked their way up into her chest. And this is why she was having so much chest pain. So, they had to cut her all the way down her chest and abdomen and pull those intestines down through that esophageal hiatus, or down through that tear in her esophageal hiatus, down through that hiatal hernia, back into her abdominal pelvic cavity and kind of arrange them where hopefully they wouldn't get tangled up, and then close up that hiatal hernia and then sew her back up. You guys, this also can happen when a baby is developing in the mother's womb. There can be a tear in this esophageal hiatus. The intestines can actually work their way up into the baby's chest cavity. And you guys, usually this is fatal because if the intestines are up in the chest cavity, then a lot of times the heart doesn't develop properly because the intestines are in the way. It causes the heart to not develop properly, and so when the baby's born, it has heart defects and it can't survive. I actually have another personal story about that as well. My husband's sister's daughter was pregnant, and within a few hours after the baby was born, the baby started having trouble breathing. They had had no indication that there was anything wrong up to this point. They finally did some tests and determined that she had a hiatal hernia, and part of her intestines were up in her chest. Luckily, they had not interfered with the development of her heart. They had, however, interfered with the development of one of her lungs. And so they had to do surgery. They had to pull that baby's intestines back down into its abdominal pelvic cavity, close up that hiatal hernia, try to arrange those intestines so that they would not become entangled. And she had one fully developed lung and another lung that was only partially developed, just like a little stub of a lung. Since she was a baby, however, that little part of a lung has grown some. So she has a bigger part of a lung there, but she still does not have two complete lungs. So she has to be very careful during the winter months with things like the flu. Also, obviously, this coronavirus would be a definite concern for her. She's also never been able to play sports because with one entire lung and part of another lung, she would not be able to exchange enough oxygen to be able to do vigorous physical activity. And obviously, any kind of respiratory illness would be very dangerous for her since she doesn't have two complete lungs. Moving on, at the end of each portion of our digestive tract, we have a sphincter muscle. A sphincter muscle is going to be very similar to the valves of the heart. The sphincter muscles help to prevent backflow. So they open to let material flow from one portion of the digestive tract to the other, and then they close to prevent material from backing back up into the part that it just came from. Also, these sphincter muscles can help control the movement of material, so they can slowly release materials from one part to the next. The sphincter muscle at the end of the esophagus is called the gastroesophageal sphincter. Again, gastro for stomach, esophageal for esophagus. So it is the junction between the esophagus and the stomach, the gastroesophageal sphincter. It prevents backflow of stomach materials into the esophagus. Now, the problem with this can be that you can have a weakened or permanent relaxed gastroesophageal sphincter. If you have a weakened or permanently relaxed gastroesophageal sphincter, then basically what's going to be able to happen is all this acidic material in the stomach is going to be able to back up into the esophagus. Okay, that acid was not meant to be in the esophagus. So this can lead to esophagitis, which is inflammation of the esophagus as the gastric enzymes and acids backflow into the esophagus and erode its tissues. This is what causes heartburn and can also cause acid reflux disease. I actually have acid reflux. Another personal story here. I have what they call silent reflux. My only symptoms were that I was really hoarse. I kept getting hoarse, and I thought, well, it's because I teach. I talk so much, and I kind of talk loud too, and I talk fast, and I talk a lot. So therefore, I thought I was just hoarse from teaching. But it kept getting worse and worse and worse. Well, my aunt had some growths on her vocal cords that made her hoarse, and she had to go to the doctor and had to have surgery to have those growths removed. So then I thought, well, maybe I have growths on my vocal cords causing this hoarseness because it kept getting worse. So then I go to the ear, nose, and throat doctor. And he looks at my throat and my voice box, and he says, it looks like someone has stuck a match to your voice box. Do you have heartburn? And I was like, no, I never have heartburn. And I was like, my only problem is that I'm hoarse all the time. And I said, I have noticed sometimes at night I will wake up choking. I said, I just thought that it was drainage, that I was having drainage from my sinuses into my throat, and I would wake up choking at night. And he said, no. He said, you have what we call silent reflux. You have acid reflux, but you don't have the heartburn that usually comes along with it. And he said that choking at night is where that gastric material, that acidic material from your stomach is backing back up into your esophagus, causing you to choke, and it's also eroding your voice box, and that's what's making you have this hoarseness and making your voice box really red and inflamed. It looks like somebody stuck a match to it. And so I had to start taking acid reflux medication. I actually take generic Nexium right now. Again, this esophagitis, guys, can lead to esophageal cancer, okay, which doesn't have a really high survival rate. So if you have heartburn more than just occasionally, then you need to go to the doctor and have this seen. Just because you're young, my son has been having heartburn for years, and he's just 24 right now, and he really needs to be on heartburn medication, but he won't go to the doctor and get it. If you have more than just occasional heartburn, this acid going back up into your esophagus can erode your tissues into your esophagus, which means the cells have to divide more often. And you guys, every time cells divide, you have a chance of a mutation forming, happening and resulting in cancer. So this esophagitis, this inflammation and erosion of your esophageal tissues can lead to esophageal cancer. So if you have more than occasional heartburn, you really need to go to the doctor and talk to the doctor about what you can do to combat that. Okay, again, here we can see our esophagus. Here's our trachea, which is our windpipe. Here we have our epiglottis. So when we swallow, this epiglottis folds down over this opening to the trachea to keep the food from going down the windpipe so that the food can go down the esophagus to the stomach. Okay. Another name for mastication is chewing. So our lips, our cheek, and our tongue of our mouth help to keep the food between the teeth so that we can chew it and mechanically process it. Deglutition, remember, is swallowing. The tongue is going to block off the mouth. The uvula will rise to block the nasopharynx. The epiglottis will fall to block off the trachea and lower airways as the larynx rises. And this allows the food to go. Remember, those muscles of the esophagus initiate the process of swallowing, and this is how we swallow to get the food down our esophagus into our stomach. Again, Swallowing is a reflex. So once you begin swallowing, you can't stop. So when that food reaches those muscles in the back of the in the pharynx, then acetylcholine is released, and that reflex happens, and automatically those pharynx muscles and esophageal muscles start contracting, and that swallowing starts, and it cannot be stopped once the food triggers the release of acetylcholine from those the neurons in that pharynx. Here is a good video that will talk about the stomach structure and function, so I would suggest watching it because it will help you understand the material that we're going to talk about next. The first thing we want to do is talk about the structure of the stomach. The stomach is a temporary storage tank of food. It is roughly a J-shaped pouch. I really don't think that it's shaped like a J, but that's what a lot of the textbooks say. We will look at a picture of the stomach in a minute and label it. You will also have to label a stomach in your interactive notebook. Again, you guys, the main function of the stomach is more mechanical processing. There is very, very little chemical digestion that happens in the stomach. A little bit, but not a lot. So what is the purpose of the acid in the stomach? Well, number one, the acid in the stomach does provide a low pH so that the enzyme that is in the stomach that is doing a little bit of digestion can function. But the main purpose of the acid in your stomach is sterilization. You know, there could be many bacteria, parasites, things like that in the food that you swallow. So that acid helps to kill a lot of the pathogens that get in through your mouth and nose. When you swallow them, they go into the stomach, and the stomach acid kills them. So the main purpose of the acid in the stomach is to sterilize the food, to kill any pathogens that might be in anything that you're swallowing. But again, the acid does help to provide a low pH so that the one digestive enzyme that is in your stomach can do its job. The stomach, all that segmentation, remember, the stomach is one of the main places where segmentation happens. All the mixing and churning that happens in the stomach turns that food mixed with gastric juices into a thick, acidic, soupy mixture called chyme. Looking now at the regions of the stomach, let me plug up my computer real quick before it goes dead. The regions of the stomach, the first one is the cardiac region. This is the smallest portion of the stomach. It is right there where the esophagus attaches to the stomach. You have glands in this region that secrete large amounts of mucus that protect the connection with the esophagus from gastric acids and enzymes. So again, we don't want that acid getting back up into our esophagus, so we have a lot of glands there producing mucus that are going to help. Remember, mucus is a buffer. It helps to neutralize the pH of that stomach acid. And then again, remember, right there at that cardiac region is also where the gastroesophageal sphincter is. It opens up to allow the food to come from the esophagus into the stomach, and then closes to prevent the acidic materials in the stomach from backflowing up into the esophagus. The next part of the stomach is the fundus. It actually comes up above the cardiac region and touches the diaphragm. The next part of the stomach is the body. It is the largest part of the stomach. It mixes. This is where the segmentation is actually happening. It is mixing the ingested food with gastric juices. There's also glands in the body that are secreting enzymes, specifically the digestive enzyme called pepsin, and also the acid. The glands that secrete the acid are there in the body as well. And again, here's where those muscles, the smooth muscle of the stomach is contracting, mixing and churning the food with those gastric juices, forming that chyme. And then the pyloric region is the curve of the J, so it's going to be the lowermost, the inferiormost portion of the stomach, and it ends in another sphincter muscle called the pyloric sphincter. This is a sphincter muscle that controls the release of the chyme into the small intestine, which is the upper portion, or specifically into the duodenum, which is the upper portion of the small intestine. In the stomach, we also have folds called rugae that allow the stomach to expand so that it can hold more food during meals. So the rugae are folds that expand so that when you're eating, your stomach volume can increase to hold the food that you're eating. So here is a picture. Again, here's our esophagus. The gastroesophageal sphincter is right here. This is the cardiac region as well. Here is the fundus that comes up above the cardiac region and touches the diaphragm. All of this is the body. Here we can see the rugae. Those are the folds that it can expand to increase the volume of the stomach. And then here at the end, this is the pylorus, and this is the pyloric sphincter. And then it closes. It opens to allow some chyme to go into the duodenum of the small intestine here, and then it closes. So that way we can get a gradual release of chyme from the stomach into the small intestine. Again, you have no absorption of nutrients happening in the stomach. You have a little bit of digestion by one digestive enzyme called pepsin, and then you have acid being released to provide an acidic pH for that pepsin to function, as well as to neutralize, or I'm sorry, to sterilize the food that you're eating, to make sure to kill any pathogens that might be in it. So let's look at the 4 sets of gastric glands. The first set are called gastric pits. They secrete mucus, again, which is a buffer that helps protect the stomach lining from the acids as well as the digestive enzymes. We have parietal cells, you guys. The parietal cells produce the acid, but they do not secrete acid. And if you hear a cat, that is my cat meowing. Sorry about that. She's wanting to go outside, I think. In any case, the parietal cells do not secrete acid. The parietal cells secrete hydrogen ions and chloride ions separately. In the lumen, or opening inside the stomach, these hydrogen and chloride ions combine to produce the hydrochloric acid. Again, this keeps the pH of the stomach around 1.5 to 2, which is a very low pH, very strong acid here. And not only does it help to sterilize the food, but it also helps to keep an acidic pH so that enzyme pepsin can break down proteins. So that acidic pH facilitates the breakdown of the proteins by the pepsin. Chief cells are another set of gastric glands that actually secrete the enzyme pepsin that digests proteins. And then we have pyloric glands. Obviously, those pyloric glands are going to be in the pylorus. The chief cells, the parietal cells, are going to be in the body. And then the gastric pits are going to be in the cardiac region. The pyloric glands secrete mucus and gastric hormones that stimulate the secretion of other glands and cells, including the parietal cells and chief cells. So again, the pyloric glands are going to be secreting some mucus to help neutralize the pH of that chyme before it enters the small intestine. And then they're also going to be secreting some hormones such as gastrin. And what's the other one? Gastrin is one of the hormones. And I forget the other hormone that is being secreted in the stomach. But anyway, these hormones are going to stimulate the parietal and chief cells to secrete the pepsin and the acid, as well as stimulating some of the other glands like your pancreas to secrete digestive juices. And I can't remember the name of that other hormone. But anyway. Okay, so next we're going to be talking about the small intestine, and then we'll talk about some of the accessory organs that help the small intestine to do its job. So again, you may want to watch this video. It's going to talk more about the small intestine and what is actually going on in the small intestine to help you understand the next part of this lecture. Okay, so our small intestine is the body's major digestive and absorptive organ. It is about 20 feet in length, give or take a little bit. This is where your digestion is completed. Again, remember, a little bit of digestion happened in the mouth with the amylase, digesting the carbs. A little bit of digestion happens in the stomach with the pepsin, digesting the proteins. Most of the digestion, however, is completed in the small intestine. You will have your pancreas that will be secreting digestive enzymes that digest lipids, proteins, and carbs. And then most of the absorption also happens in the small intestine. And again, remember, absorption is where those tiny macromolecules, the little parts of the carbs, the proteins, and the lipids are going to be absorbed through the small intestinal wall into the bloodstream to be carried and nourish all the cells of your body. So we have some different subdivisions of the small intestine. The first subdivision is the duodenum, also called the duodenum. I've heard it pronounced different ways. This is considered the mixing bowl. Again, besides the stomach, this is the other place where a lot of segmentation happens. The chyme from the stomach is mixed and churned and combines with the digestive enzymes from the pancreas and the liver to form this mixture that is going to be digested to produce all those tiny molecules that can cross the intestinal epithelium. The duodenum also contains lots of glands, again, that are secreting mucus, again, helping. Not only are those pyloric glands secreting mucus to help neutralize the pH of that chyme, we also have glands in the duodenum that are secreting mucus to neutralize the pH of that chyme, because that chyme is very acidic when it comes from the stomach. We also have the jejunum. This is where most of the digestion absorption takes place. In the jejunum, we're going to see that the inside of the jejunum is very textured. It's not smooth. because it has lots of folds called places circulares and lots of intestinal villi, which are finger-like projections on the walls of this jejunum. These folds, these places circulares and these intestinal villi, help to increase the surface area available for digestion absorption. We want to increase the surface area of this jejunum so that we can absorb as many nutrients as we can from the food that we eat. And those places circulares and intestinal villi help to increase the surface area so that we can get maximum absorption of the nutrients from our food. The third and longest segment of your small intestine is the ileum. It's about 12 feet long. Again, you're still going to have digestion absorption happening here, but most of it is going to happen in the jejunum. And again, here we have another sphincter muscle. This ileum ends in a sphincter muscle called the ileocecal valve. Again, ileo for ileum and cecal for cecum. That is the beginning portion of the large intestine that is attached to this ileum of the small intestine. So the ileocecal valve is a sphincter muscle that controls the flow of contents from the small intestine into the cecum of the large intestine. And it's going to prevent backflow of materials from the large intestine into the small intestine. Because we're going to see in the large intestine we have bacteria that we need to have there that we do not want in our small intestine. So this ileocecal valve is going to close to help prevent materials, including those bacteria, from getting back up into the small intestine. We also see that there is some immune tissue or lymphoid tissue in the ileum, at the end of the ileum as well, there around the ileocecal valve. This is called these are called Peyer's patches. There's about 20 to 30 masses of this lymphoid tissue called Peyer's patches, and these contain lymphocytes or white blood cells that are going to be able to destroy any bacteria that are in the large intestine that try to move up into the small intestine. They're going to destroy those bacteria because in the small intestine, those bacteria can make you sick. In the large intestine, those bacteria are keeping you healthy. But if they get up into the small intestine, they can make you sick. So the white blood cells, the lymphocytes living in these Peyer's patches, help to keep those bacteria that are living in the large intestine from getting up into the small intestine too far. And it takes the chyme about 5 hours to go from the duodenum to the ileum. So your chymes, your food material, spends about 5 hours in the small intestine, finishing up digestion and being absorbed, the nutrients being absorbed from it. Okay, now before we go on to the large intestine, we're going to look at some of the accessory organs of the small intestine. Again, here we can see our small intestine. It is called small, guys, because it is not because it is smaller in diameter. It's actually longer than the large intestine, but it's called the small intestine because the diameter is smaller. And that's going to be it all in here. All of this darker brown that you see going around here, almost in a horseshoe shape, that is the large intestine. And we'll talk more about it in a few minutes. Okay, so now we're going to look at the accessory organs. The first accessory organ that we're going to look at is the liver. If you want to learn more about everything the liver does, then you can watch this video. It's a really good video that talks about all the functions of the liver. Okay, so our liver is our largest visceral organ. So our skin is our largest organ, but our liver is our largest visceral organ, which means our largest internal organ. It is very large. It is pretty much almost all the way across your abdomen under your diaphragm. It is firm and it is reddish brown in color. It has three major functions. The first function is to produce bile. We'll talk more about what bile is in a few minutes, but it produces the bile and transports it to the gallbladder to be stored or to the duodenum to help with digestion. Now again, bile is stored in the gallbladder, but it is produced by the liver. So the liver is very important in production of bile. And then it transports that bile to the duodenum to help with digestion or to the gallbladder to be stored between meals. And we'll talk more about bile in just a few minutes. Also, our liver is important in metabolic regulation. It regulates the composition of your circulating blood. So you're going to see that some of the nutrients from your small intestine are actually carried to the liver to be modified or else to be stored until they are needed. So the liver helps to remove excess nutrients from your blood and store them. It also helps to remove toxins from your blood. Your liver detoxifies toxic substances. You guys, most of the medications that we take are poison to our bodies. They are toxic. The reason they don't kill us is because our liver detoxifies them so that they don't hurt us. But if you take too much of that medication in, it can actually damage your liver. If you give your liver more medication, more drugs to detoxify, then what it can detoxify in a certain period of time, this actually damages your liver. It can also poison you. So it can either kill you in terms of poisoning you. That's what causes alcohol poisoning. You drink too much alcohol in too short of a period of time. So you're giving your liver more alcohol to detoxify than what it can do in that period of time. And so that excess alcohol that liver cannot detoxify poisons you and kills you. The other thing that can happen, if you're giving it these drugs, these medications, this alcohol constantly over a long period of time, that can still damage your liver. It can lead to cirrhosis of the liver, which can also kill you. It can cause liver cancer and kill you. So again, it's the best thing is to not take too much medication for too long, no matter if it's alcohol, drugs, medicine that the doctor gives you, whatever. Also, nutrient deficiencies can be corrected. Sorry, my son is getting a phone call. Nutrient deficiencies can be corrected by the liver. Like, for example, if your glucose levels are too low, then your liver actually stores extra glucose. It removes excess glucose from your blood and stores it as glycogen. So if our blood sugar is low, our liver can actually then that liver can actually break down your it can break down that glycogen and return glucose to the blood to bring up your blood sugar levels. It can also synthesize some nutrients. Your liver can store iron, which can be released into the blood if your iron levels in your blood are low, and it can also synthesize some vitamins. And then lastly, our liver participates in hematological regulation. Basically, what this means is that our liver cleans our blood. So our liver is the largest blood reservoir. If you have a liver laceration, you can bleed to death very quickly. Our liver contains phagocytic cells called Kupffer cells that help to clean our blood. They clean out old and damaged red blood cells, debris, as well as pathogens that are in your blood. So your liver actually helps to clean your blood. Your liver has 4 lobes. I'm not going to ask you about those, but you do have a right and left lobe as well as a caudate and a quadrate lobe. Again, these are just different sections of your liver. Again, your liver is huge. Again, you've heard of hepatitis before. Hepatitis is a viral infection of the liver. It causes inflammation of the liver. There are 6 different types, A through F, and it can lead to liver cancer. Here we can see our right lobe is the biggest, left lobe is a little bit bigger. The quadrate lobe and caudate lobes are smaller. And then you can also see that your gallbladder is attached to your liver as well. Your liver is a huge organ. Okay, now let's look a little bit more at our gallbladder. Our gallbladder is very small, it is hollow and pear-shaped, and it is connected to our liver. What is the function of our gallbladder? The only function of your gallbladder is to store bile, and this is why you can live without your gallbladder. In fact, in November, I had to have mine removed because I was having a lot of intestinal issues. But our gallbladder simply stores bile. Remember, bile is produced by our liver. It is stored in our gallbladder between meals. So now that I don't have a gallbladder, all the bile that my liver is producing is going directly to the duodenum of my small intestine all the time. And you guys, the gallbladder is usually going to be green in color, and the reason for this is because it stores bile, and bile is green. The bile duct delivers the bile from the gallbladder and the liver to the duodenum of the small intestine during meals. So bile will go from the liver and the gallbladder through the bile duct to the duodenum of the small intestine during a meal. Again, between meals, then the bile will go from the liver to the gallbladder. If you have gallstones, which thankfully I didn't, it can be very painful, but basically the bile salts crystallize and form little crystals in the gallbladder, and then they have no way to get out. Now, you can have stones in your gallbladder and be fine, but if those little stones get into that bile duct and start trying to move, that's when they cause a lot of pain. And treatments for those include taking your gallbladder out. That's the surgery. Some drugs can dissolve the stones if there's not very many, or you may have to. They also can use lasers to break them up. Again, here we can see our gallbladder. Here is going to be the bile duct that is going to be leading to the duodenum of the small intestine. And we're also going to talk about our pancreas. But before we talk about our pancreas, let's talk about what is bile. We've talked about bile is produced by the liver, bile is stored in the gallbladder between meals, bile is transported from the liver and gallbladder during meals to the duodenum of the small intestine to help with digestion. How does bile help with digestion? Well, You guys, our pancreatic enzymes, the digestive enzymes that we're going to talk about in a few minutes that are produced by our pancreas, are water soluble. We know that lipids or fats are insoluble in water. So these water soluble enzymes have to digest fat that's not soluble in water. So basically these fats in our food cluster together in the chyme. They cluster together into these big droplets of fat. And these little water-soluble enzymes are in the water around the fat trying to digest that fat. Well, if you have a large droplet of fat and those enzymes can only get to the outside of the fat, then it's going to take forever to digest that fat. And it's not all going to get completely digested before it goes through the small intestine and gets to the large intestine. Again, those water-soluble enzymes can only attack the surface of that large fat droplet. So what does bile do? Bile is an emulsifier. It does what we call emulsification. What this means is that it breaks those large droplets of fat into many smaller droplets of fat. This increases the surface area available for attack of those pancreatic water-soluble enzymes and helps the fats to be digested much more quickly so that all the fat in the food that you eat can be digested before the material gets to the end of the small intestine. Again, if you remember us talking in chemistry, when you took chemistry, you did the experiment where you put the Alka-Seltzer in water and the tablet that was crushed into pieces reacted and disappeared much more quickly than the tablet that was whole, because the tablet that is in pieces has much more surface area in contact with the water so that it reacts much more quickly. It's the same thing here. The large droplet of fat is like the whole Alka-Seltzer. It only comes in contact with those water-soluble enzymes on its outer surface. But if we use the bile as an emulsifier and break that large Alka-Seltzer, that large droplet of fat, into many pieces, then the water can get to the inside of the Alka-Seltzer. The water-soluble enzymes can get to the inside of the fat droplet because we've broken it into small pieces. And so we're increasing the surface area available for enzyme attack so that large droplet of fat can be digested much more quickly. Okay, our last accessory organ that we're going to talk about is our pancreas. Here is a good video about your pancreas, talking about the structure and function of your pancreas to help you understand that information a little bit better. Your pancreas is found in the greater curvature of the stomach, and that reminds me, I want to go back and talk about the curvatures of the stomach real quick before we talk about the pancreas because I forgot to do that. Okay, this is the lesser curvature of the stomach. This is the greater curvature. Again, greater curvature is a bigger curve. Lesser curvature is a smaller curve. I just wanted to point that out because I forgot to earlier. Okay, so again, the pancreas is found in the greater curvature of the stomach. Again, so it's found at the posterior part of the stomach, at that greater curvature, kind of behind the stomach. It is long, pinkish gray, and lumpy. It's not smooth. The liver is more smooth. The pancreas is going to be lighter in color, and it's going to be more bumpy and lumpy, and it has more of a texture to it. And it is mainly an exocrine organ, meaning that it secretes digestive enzymes and buffers that are going to be delivered by the pancreatic duct to the duodenum of the small intestine. So the digestive enzymes that it secretes include lipases that digest lipids, proteases that digest proteins, and amylase that digests carbs. Also, our pancreas secretes a buffer in the form of the bicarbonate ion, the HCO3 minus ion. This is another buffer this is a buffer that is delivered to the duodenum, just like we have glands in the pylorus of the stomach, and we have glands in the duodenum that are secreting mucus to help neutralize the pH of that acidic chyme. We also have bicarbonate ion that is being transported by the pancreatic duct to the duodenum of the small intestine to help neutralize the pH of that acidic chyme that is being transported from the stomach into the duodenum of the small intestine. And then, of course, these digestive enzymes are going to be digesting the nutrients. And these are the enzymes that digest most of the nutrients, most of the carbs, proteins, and lipids in your food so that they can be digested into small pieces that are then transported across the small intestine's epithelium into the bloodstream. Exocrine organ means that the secretions end up reaching the outside of the body. So again, all of these secretions of the pancreas go to the duodenum of the small intestine, then end up in the large intestine, and then eventually end up being pooped out into the toilet. Okay, but our pancreas is also an endocrine organ, guys. Endocrine meaning that secretions enter the bloodstream and never reach the outside of the body. As an endocrine organ, the pancreas secretes two hormones called insulin and glucagon, which help to regulate our blood sugar levels. So if you remember, when we talked about the skeletal system, we talked about parathyroid hormone and calcitonin and how they worked in opposition of one another to keep the blood calcium levels at a certain level. Well, the same thing is true for these hormones, insulin and glucagon. They work together to keep your blood sugar levels at a normal level. If you have too much sugar in your blood, then the pancreas cells will release insulin. This insulin will stimulate cells to use the sugar in the blood for growth and energy, or it will stimulate muscle cells, for example, to use the sugar to take up that sugar and store it as glycogen. It will stimulate liver cells to take up that sugar and store it as glycogen. It will stimulate muscle cells to use that sugar to contract, to grow, to divide, things like that. So again, that takes sugar out of the blood so that it will lower the blood sugar level if you have too much. If you have too little sugar, then your pancreas is going to release the other hormone, glucagon. This glucagon will stimulate cells to reduce their use of glucose. It will stimulate muscle cells to store or to break down their glycogen and release glucose into the bloodstream. It will stimulate liver cells to break down their glycogen and release glucose into the bloodstream to bring up those blood sugar levels. So again, these two hormones, insulin and glucagon, work together to keep your blood sugar levels constant. And here again, we can see our pancreas up here kind of in that greater curvature of the stomach behind the stomach. It is long, kind of lumpy, and nodular, and light in color. Okay, the last part of the digestive system we need to talk about is the large intestine. Again, watch this video. It will give you some really good information about the structure and function of the large intestine. The large intestine begins at the end of the ileum of the small intestine and ends at the anus. It is roughly horseshoe shaped. Again, it is called the large intestine because it is larger in diameter than the small intestine, but it is about half as long as the small intestine. So if our small intestine is around 20 feet long, then our large intestine is around 10 feet long. Again, that's just give or take. It's an average. But anyway, the reason it's called large is because it is larger in diameter than the small intestine. The functions of the large intestine include reabsorption of water and bile salts. So there is a little bit of absorption that happens in the large intestine. When the material moves from the small intestine to the large intestine, then the material is still pretty watery, and we don't need to be pooping out all that water. I mean, that's when you have diarrhea. If material doesn't spend enough time in the large intestine, if it goes through the large intestine too quickly, then you have diarrhea. If it goes through the large intestine too slowly, then that's when you're constipated. So the longer the material is in the large intestine, the more water is reabsorbed. So again, and that's very important because if you have diarrhea too much, then you're getting rid of too much water and you can become dehydrated very quickly. So that is a very important function of the large intestine, is to reabsorb a lot of the water that is in that material that's leaving the small intestine. Also, anything else that's in that material that comes into the large intestine can be reabsorbed, like bile salts. So there is some absorption happening in the large intestine. Most absorption of nutrients happens in the small intestine, but there is a little bit that happens in the large intestine. As water is reabsorbed from the material, then that material entering from the small intestine, that chyme, is compacted. It's kind of mushed together into feces, which is your poop. And also we have some absorption of vitamins, such as vitamin K, biotin, and other B vitamins happening in the large intestine. This is why we need those bacteria in our large intestine, guys. To us, the material in our large intestine is waste, but to bacteria living in our large intestine, that is food. So we have a symbiotic relationship, a mutualistic relationship with the bacteria in our large intestine. The bacteria in our large intestine use our waste for food, and in return, they give us vitamins that our body can't make on its own. So these bacteria are good in our large intestine. We need them there. They're producing vitamins that can then be absorbed across the large intestinal epithelium into our bloodstream. So we have absorption of water, bile salts, as well as vitamins being produced by bacteria in our large intestine. And the main function, however, of our large intestine is to store our feces, our poop, until defecation, until we go to the bathroom. The divisions of our large intestine, there are actually 5 divisions, but this colon actually has several different parts. The colon is the biggest part of the large intestine, so a lot of times our large intestine is referred to as our colon, but there are other parts as well. The very first part attached to the small intestine is the cecum. It collects and stores the chyme and begins the reabsorption of water and the compaction of the chyme into feces. The next portion is our appendix. You guys, your appendix is actually a part of your large intestine. It is attached to your cecum. And again, it is lymphoid tissue. It is an immune organ that contains white blood cells, similar to the Peyer's patches. It is going to help keep too many bacteria from being in this cecum, because the more bacteria there are in the cecum, the more likely the chance is those bacteria would get up into the small intestine where we don't need them. After the cecum, we have the colon. The colon is the main portion of the large intestine. It is the main horseshoe shape. You have the ascending colon that goes up, the transverse goes across, the descending comes down, and then the sigmoid kind of comes over a little bit to the rectum. And your colon is very large. It actually contains pouches called haustra that permit the expansion and elongation of the colon. So like the rugae in the stomach permit the stomach to expand to hold more food, well, the pouches, the haustra in the colon, permit the expansion of the colon so that it can hold more feces. So again, most of your colon is mainly where your feces are going to be stored. Once the feces move into the rectum, that triggers your urge to have to go to the bathroom. Now, you don't have to go right away, but you're going to start getting that urge that, oh, I need to go to the bathroom. So your rectum is expandable and just temporarily stores feces. Once the feces moves into the rectum, then you're going to start feeling the urge that you need to go to the bathroom, and you're going to be able to hold it for still a little while, but you're going to start feeling the urge that you need to go. The last part of the intestine, the large intestine, is the anal canal or the anus. And you actually have two sphincter muscles that guard the opening. You have an internal and an external sphincter. The internal sphincter muscle, the internal anal sphincter, is just like all your other sphincter muscles. It is smooth muscle and it is involuntary. You have no control over it. So when materials move from the rectum into the anus through that internal anal sphincter, then you've got to go to the bathroom now. You've got to go like really quick. But you can still hold it for just a little bit, because this external anal sphincter is voluntary muscle. It is the only sphincter muscle that's under voluntary control. And so once that feces moves from the rectum through that internal anal sphincter into the anus, then okay, you've got to go to the bathroom. You can still hold it for just a little bit because that external anal sphincter is voluntary, but you're not going to be able to hold it for very long. You have powerful peristaltic contractions called mass movements. So again, peristalsis, but special name because they're very powerful, that move the feces from that rectum into that anus and cause that conscious urge, I've got to go to the bathroom now, and you can't hold it very long. Again, these are called mass movements, and they're different than the peristaltic contractions in the esophagus and in the stomach and in the small intestine. The peristaltic contractions in the esophagus, stomach, and small intestines are not as powerful, and they're more continuous. Whereas in the large intestine, these peristaltic contractions are much more powerful, but they don't happen all the time. They happen in spurts to move the material along. And so they're called mass movements. Again, fiber in your diet helps with these mass movements. It helps these mass movements be stronger. So lots of fiber basically is giving your colon a good workout, helping to move that material better along that colon and into the rectum and anus for defecation. It will keep you more, and that's how it keeps you more regular, and it helps to prevent cancer. And then here is your large intestine. Here's your cecum. Here's the anus. The appendix, the vermiform appendix. Here is your ascending colon, transverse colon, descending colon, sigmoid colon. Here is your rectum, and this is your anus or anal canal. And that is it for the digestive system. I know this has been a kind of long video, but I thought I would go ahead and go through it all in one video rather than doing two separate videos. And this way you can stop it, go back and listen, pause it, and listen to the rest of it later. Do it all at once. It's totally up to you. Please let me know if you have any questions or comments, and we'll talk to you later. Bye-bye.